Welcome everybody. Thank you for joining tonight. Tonight I'll be presenting how you will design enterprises with Mendix. A lot of us are Mendix consultants. We build applications with Mendix, and often these applications are built for enterprises. So large applications, business applications, not for consumers. Online, you read a lot of information on how to design well, how to design for consumer applications, websites, conversion, everything. Tonight we'll be diving into the differences consumer and enterprise applications and the particularities of designing for applications. So this is the outline of what I'll be talking about today. So let's set the basis. What user experience and why it's important. The key differences between consumer and enterprise UX. Then we have a framework of thought, systematic approach on solving enterprise user experience challenges, and with a small recap. So, what is user experience and why is it important? User experience, in short, is the entire scope of interactions a user has with the application, the entire brand, and with the product. It begins before they even start the application, start using it, and it ends even well after they've used it. It's how they feel. It's how they use it. It's I have slides for this, by the way. In short, it's at least all of this. It's efficiency, it's delightful, it's easy to use, and it's much more. So user experience, as the name mentions, it's the experience of the user. Interestingly, if you do that, if you don't invest enough time, which often happens, you will get some costs. So first of all, for consumer applications, you can lose customers. I think we've all had this. We probably all had this. You go to the App Store, you have an idea, you want to download a music app or a different app, download it, install it, open it, and you think, oh, what is this? It works horribly. After 2 minutes, you deinstall it and you choose a competitor. Lower conversion rates. If you have an e-commerce website or you have to generate sales, people can't use their software, can't use your application, and you can't generate sales. And you can damage your reputation. A very interesting case of this. In January, Google released Google Gemini 1.5, and it was a bit of a shaky release because with all the best intentions they had, they built guardrails for bias in AI. However, it went a bit too far. For instance, if you ask for an image of the Pope, it would show a woman or a young person. The intention is very good. Historical accuracy, not so much. But this impacted how people thought, well, how well Google Gemini worked. The impact of this was their shares dropped by 4% overnight. I'm going to highlight that user experience in enterprise applications. What does this imply? Well, enterprise applications, so software you use internally. For instance, Studio Pro is an enterprise application, and developers are all power users. Timesheet applications, so things you don't use daily, but you have to use for your job. It's all enterprise applications. Inefficiency, so if you can't complete your work, or if you take too many clicks, or you can't find information, you can't do your job, it will take too long to go through it. High training costs. If you have a very large, complex application, and you don't know how to use it, but you say, oh, just write documentation and make some videos, people will learn it. However, that costs time, people won't remember it, they can't use your application. High support costs. If people can't use it and they have to ask other people, they don't have one person not working, you have 2 people busy solving a problem that could be solved by designing it well. Inability to accomplish work, and Personally, I really don't like working with products that don't work well. It affects my mood. I think it's very annoying to work inefficiently. But how much does it actually cost? I can tell you this, but down the line, how will you convince the business owners on investing in user experience? Imagine you have an application with 10 users. Your average cost be about 30 euros per hour, and you save 1 hour per day. In a year, you would save 100,000 euros. For large applications, imagine a timesheet application where people have to enter the time daily. Perhaps a large organization, 50,000 people. And you would save on a yearly basis 8 million euros in productivity. Okay, you might not translate it directly every minute to productivity. Even if you halve it, if you divide it by 10, divide by 100, we still have 80,000 euros saved if you divide it around. So it's worth investing in good user experience to help people be productive. Now we know why it's important. Let's highlight the key differences between user experience for consumer applications and user experience for enterprise applications. Consumers, well, they can decide which app to download, which apps to install. For instance, a good example is Spotify. You want to listen to music, do a lot with it. Consumer applications are often focused on individual use. So you install your app, you use it. It often has one simple function. Imagine, Spotify. You can play music, listen to podcasts. You can download it, listen offline, discover music, but it's all related to a single subject. It's all related to best experience listening to music. Usually they short bursts of use, so it's not for daily use. It's a generalization, not for all applications. People want to be able to use it immediately. So if you download the app and you onboard it, you want the users to know how to work with it, because people don't have patience to learn how it works, especially if they have plenty of other options. Personalization is often a important part. They can give people a sense of ownership and put it to their own personal needs. The last one is performance. It has to be fast. Because, for instance, I think I didn't mention yet, enterprise applications, the cost could be millions. For consumer applications, for every 100 milliseconds, your website takes longer to load, you lose 1% in conversions. A good example, a consumer app is Deezer. It's a music listening app. Like that of Spotify, you can listen to music, discover it, create playlists. It's all good in music. Enterprises, it's a very different focus. It's designed for the business domain. So it's not for a single user. It's designed for groups of people. It's groups of specialized users, and people who have to approve items, people who have to make requests, people who have to enter their hours, and much more. Often, not always, people are power users, which means they use it daily, frequently, hours on end, which means that small changes can have a big impact. Focus on productivity and efficiency. You want to prevent errors and ensure that people can work comfortably. And in contrast to consumer applications, aesthetics are less important. But user experience is more than aesthetics. It's also how it works. It's also how efficient you can work. So this is a quick example of a virtual machine managing application. And for here, you can see it's a lot of navigation, a lot of features. Interesting one is the cursor here has a deep drill down of information, but you can see a summary. The compute health checks that there's one thing he needs to visit. So even though there's a lot of information, the user does know where to go. What are the different user goals? Consumers, convenience, entertainment, speed of use, so this is for leisure. Enterprises, productivity, efficiency, taking your tasks. Now we've talked about why it's important. The differences are, now for enterprise applications, so we'll not be focusing on consumer applications, we'll be focusing on the applications we often build. A systematic approach for solving these problems. We have a set of 6 different challenges, 6 important challenges you often have with user experience, and then a systematic approach on how to solve those. First of all, we want to maintain consistency within your applications. Inconsistencies can make your users imagine you have a form, and for different forms, the button layout is different, the coloring is different, icons have different meanings. This hinders the habit forming process of your users. People who use it frequently, who use it daily, they create a habit of using it, they have expectations. These things are inconsistent, they can either lose their work, make mistakes, or let's think for an extra second. To manage information overload, with the example you just saw for managing virtual machines, or anything, a lot of information. How will you present it? How will you do it in such a way that the users can go from back to forth to the job without having all the information you can show? It's your data consistency. This is partially a data problem or a data challenge, It's also going to affect the user experience. So if you have error in your data, you not only have to solve it yourself, you also have to solve it with other users or even other teams of different applications, which could also hinder productivity. And this could be a result of poor user experience implementation, for poor interaction with your application. The greatest productivity gains are usually with repetitive actions, especially unnecessary repetitive actions, and optimizing data interaction and display. I'll go through this. Also go through every example. Look at the next slide. The systematic approach. Well, how would we approach these challenges? Well, things user experience designers usually like to do is ask, well, how might we do this? Well, let's do a simple 3-step solution, systematic approach. Well, first of all, the most important step is identify. So identify where the problem is. If there's a problem, or an opportunity to make it more efficient. If you don't know where the problem is, you can't solve it. And you can solve the problem. Every challenge has their own particularities, and these solutions, or these how to solve it, is based on generally accepted user experience principles. And finally, if you've made a solution, if you made an agreement on how to solve it, implement it throughout your application landscape further. Where does this fit in our process? Well, I will reduce it to working agile. Identify. When will you look for user experience issues? Well, this is in the testing phase, I would say. So take a moment with your users, with functional beheerders. Take a moment with your users, go through the application and see where they are hindered, where they can't work efficiently. We'll also talk about this in the next following slides. Solving it will be in the design phase. Implementing it will be in the build phase. So it all has their own place in the Scrum process. First of all, maintaining consistency. How do we do this? Set aside a few hours. You can do this every sprint. So you systematically allocate time to solving user experience problems, because in the slides where we talk about why it's important, you can save a lot of money with this, or a lot of lost money. Inconsistencies could be about form layouts, about semantic coloring. Is every type of information presented the same way? Is orange always a warning? Is red always an error? or it could be something different. Consistency reduces complexity. If it's not consistent, it will interfere with your habit forming process. Well, how would we solve this? Of an example of forms in Mendix, you can use the defaults. You have a vertical form layout, buttons on the left. Imagine somewhere else, you have a different pop-up form. You put the buttons on the right. Well, this might hinder your progress. And for a different form, you could even have different coloring for the same buttons. These are small examples. But for instance, if someone fills out a large form, okay, these are very small forms, but if someone has a large form, a lot of data entered, and your cancel button looks like primary button, you click on it and you lose all your data. Or if the locations of save and cancel are swapped, you're used to clicking on the right button, you click save, click on the cancel button, you lose all your data. So how do we solve this? Decide on the correct pattern. We always use vertical form layouts. We always use primary buttons for save. We always put the buttons on the right. Always the primary action at the complete right. Use this for every form to watch application. And users always know what to expect. We also prevent them from losing data. When we implement it, apply the same patterns to similar UI elements, components, and organisms if you studied atomic design. So it's not only form layouts, you can also have semantic button coloring, the same, the meaning of icons, for instance. Do you use the icons consistently, like a pencil to edit, or a plus to add, or do you say something like, you want to create a new one? Do you use create? Do you use save? Do you use submit? There are different wordings, and they can have the same meaning or different meaning, but you don't want to leave users guessing. Next of all, managing information overload. This is often an issue with enterprise applications because we have lots of information, lots of things to do, lots of features. Well, how do you identify this? Take a moment with the users because you're not the one to decide often. What is their essential information they need in their tasks, from beginning to the end, to finish their task? So what do they absolutely need to see at all times? Then you have your supplementary or secondary information. This could be hidden somewhere. This could be unfindable. But this should be accessible quickly and in the right context. And background information, that's tertiary information. This can be like audit trail information, history of objects. This is not important to see, but should be accessible. How do we solve this? There are different UX paradigms to solve this, or methods or different approaches. One is progressive disclosure. It's a very simple example. If you have a form with a lot of inputs, but some are dependent on others, then you have the radio buttons, and one is put the project on hold. And you click on it, and you show a different form, different input, which is only shown if you put it on that option. It's a very simple example, but it does reduce the amount of elements someone sees in the interface. And if you can reduce it even more and more, you can assure that someone is not mentally overloaded with way too much information that might or might not be necessary. Contextual help. If you can't, you don't want to. Like a good example is when you do your taxes. Almost every field has a small question mark with a lot of additional information. When you fill it out, you know what to do. If you would show all the information at once, you would have to scroll far down to fill out your text forms. When we implement this, there are a lot of standard Mendix widgets which are excellent at doing this. Accordions, they hide content, and they will show you the content based on when you need it. You can use tabs, wizard steps, but be careful with wizard steps because this could hinder someone from quickly making progress. So if someone is like a power user and they use a tab a lot and they use only the keyboard to fill out to do their work, with wizard steps you might undermine their their quickness in the system. And of course, dynamic tooltips and dynamic form fields and tooltips. My apologies. Ensure data consistency. How do we approach this? First, you identify where you could have data inconsistencies. For instance, date formats. All seen the European notation and the American notation. 1 day, year, or day, month, year. How do you solve this? During refinement or a different moment, agree on a certain pattern and also decide if it's critical information. If discrepancies don't hinder the system, you could live with it. You could also just make it consistent and implement it by building it in the next sprint. Reducing unnecessary and repetitive actions. Also, start by sit together with the user and note all the actions they take in an end-to-end flow. Identify any repetitive or unnecessary actions. You can solve this by minimizing the clicks. There's a whole list of things you can do. Let me quickly show you an example how to do this. Hope this one is still running. Yep. Made a small, not really exemplary project. Get the point across. Imagine you have project management software and you want to edit it. Imagine someone has to edit it a lot, like on a daily basis, multiple times a day. Should be sharing. Really good points. Yeah. So for instance, you have project management software, edit it. Input fields, so everyone knows how it works. You click on save. Great. You get this pop-up. You save successfully. Is this pop-up necessary? I don't think so. It's an extra click. The user has to move the mouse from edit to OK. You have to do this as well. It's not very handy. How can you accelerate this? Well, you can use keyboard shortcuts and you can use those notifications rather than pop-ups. Let's change something right there. Control S, save it, and get those notifications. If this is someone's primary workflow, you can also, for instance, press Control N for creating a new task, new project, type everything, type everything, Control S. You don't need to use your mouse. This can save people a lot of time and make them more efficient. Yeah. So implement this by using those notifications, reducing clicks, because it's very easy to introduce extra actions for users by using standard components. But be wary, you could introduce extra friction or extra actions. Next one, optimize data interaction and display. Often people work with large data sets. They want to personalize it. Technical difficulties. So ask your users how to navigate through the application. One moment. So ask your users that will go to the application to navigate often back and forth between very deeply nested information. Help them by using persistent customization options for data grid filtering. Mendix does this greatly with data grid 2. For instance, every month they need to create a report of data. So need to change the columns, filter data, create a report. Let them save that configuration. So it'll be handy when they need it. Do they need to compare data from very deeply nested items? Well, create a pattern to show them in comparison next to each other. For instance, we have see this later on in the presentation of Wouter. You can see two pop-ups, and you can see them side by side. You can compare the information. For someone who has to compare information a lot, you don't want to have them click on multiple pop-ups, move them around, keep scrolling in both of them. This will help someone with their workflows, making them more efficient. navigation efficiency and depth. And here I've moved quickly, so I'll click through it. Spend time with your users and note the actions in your workflow. Do they know where they are in the application? Give them shortcuts. So for instance, someone might have a deep drill down in information, which have access a lot. And you can do this by quick links and help someone know where they are in the application by using breadcrumbs. This gives them control, this gives them freedom. This might be a nice example of someone who has to access data deeply quickly. You could be look at more nested data. You have a list of items, you click on one button, and it opens multiple pop-ups, and it highlights the information they want to know. It's also an acceleration of someone's workflow by reducing the amount of interaction they have to make with the system. So, small recap. What is user experience and why is it important? Well, you can save a lot of money with it if you do it right, or it can cost a lot of money if you do it wrong. The differences between consumer user experience and enterprise user experience, and a systematic approach for enterprise user experience. And remember, user experience design is always human-centric. Remember how I said with all the different challenges, start with sitting together with your user, walk with them through the application, identify your issues, because you can do a lot of things on your own, but you're not the exemplary target group. That's why it's called user experience. As a developer, you are in control of people's experience in their workplace, so make sure it's a good one. Thank you.
Right, so next part of the presentation will be about data versioning, which can be kind of a tough cookie to crack. So first off, before I start, I'd like to say that anything I'm presenting in this meetup will be shared with you so that later on you can actually look at it, explore it yourself, see the code, snag a few little bits for your own personal module that you put in each project. So by all means, go and do that. So don't be worried. All right, so imagine we have Rico here. Rico, what's your age again? 31. So the version of Rico, he is currently with a nice dark hair, right? So imagine that when he was 3 years old, he might have had white hair. So that version of Rico was different. He was smaller, etc. And so if you put all of these versions of Rico in time, and you want to track that in a system, then how do you do that properly? Who of you has thought of versioning in their own Mendix application so far? Just to see a few hands. And yeah, a couple of you have. Interesting. Cool. So let's start right off. If this is working, is it turned on? It's not working, so I'll just use my keys. If that is working, it's also not working. That's working. Excellent. So we'll look at 4 main categories. First of all, the problem, then we'll look at the chain model for versioning, a proper UX pattern, and then some other considerations that you have to keep in mind when using this pattern, basically. So the problem, about 6, 7, 8 months ago, I think we were asked, hey, we need versioning in our application for forms, basically, because basically law mandates it. So we need versioning, and each and every version needs to be tracked. And so we started getting a headache because the system was already quite complex. So we were thinking, how do we implement this, basically? So it was for a client in big pharma, basically. So we started thinking, and then first off, what is data versioning in itself? So usually you have a couple of WH questions, right? So what in this case is an entity, probably. It could be a product or a car design. And then the amount of change would be maybe one attribute, maybe only when a certain attribute changes and not the other, right? That's the amount. The who is the person triggering the actual change or the version to come into existence. The when, could it happen once that we get a version? Someone decide at a point in time that we get a version. Maybe there are multiple of those. Maybe you'll have a first version, a final version. You could have stuff like that. And then you might actually want to record some sort of location, maybe in an endpoint or a user screen, so that you can actually check where the change is made. So basically, then you could say that versioning is storing the what, how much, who, when, where, etc. And it's basically up to you to decide what exactly you want to put in your own application. Usually, it also applies to businesses in which this context is very important. So I already gave you one in the big pharma where there is a GXP. So it's really important legislation in that sense. I think in HR, the same would apply. And there are probably very many domains where the same would apply. So this is an example of the IT domain. You probably all recognize this screen, or you will have seen it likely. It's a Jira history from a ticket that I made. And what we can see right here is the who and the, the what, how much part, the description of this ticket. And then when it was changed. But as you can see as well, we're only seeing that single attribute, right? It's just the description. We can't see the entire ticket as it used to be at that point in time. And so even though this is an accurate form of versioning in which you can track changes over time, you need to do a lot of puzzling yourself in order to get back to that specific version over time, the 3-year-old Rico, right? And we may actually want to serve up that version that existed at that point in time altogether in its full context. So basically, this is a topic that's been visited by many people already. And the question is then, how do you translate that to Mendix, right? And then also, of the versioning paradigms that exist, today we will focus on a chain version with one temporal dimension. So I'm very sorry, no two temporal dimensions. What does that mean? Let's say that you've got wages in January, right? You're earning 2,000 euros, and then in March, due to some kind of agreement with a labor organization, you need to get an increase of 5%, right? So stuff like that happens in HR, where wages can be offset backwards, right? So that's when you need a time that you actually put in the information and a time that you record the information. That would be 2 dimensions. Chain versioning will work with 2 temporal dimensions, but to keep it a bit simple today, we'll just stick to the one version, which I think will work for most of your Mendix applications. Okay? But temporal meaning time. Okay, so if you'd like to read up more about these paradigms, I think this is an excellent source which you can look up later on because you'll be getting the presentation. So what would it look like to do some kind of versioning in real life? I imagine where we have no computers, but we still want to do versioning, right? So we have a document on paper, and then there is some sort of intent that you want to create a version, right? You know, okay, if I'm going to paint in this, then I can't track who did what changes when and where. So let's make a copy and start working in that. And then actually, if you want to decide to put it away in the storage cabinet, then you might actually want to look at the new version and say, oh yeah, has something changed indeed, or is this something that we've been? It's not important. So usually you check whether something has changed. And if so, you store the who, what, where, why, when, and you write down all of those bits. And then very importantly, there's some kind of link from the one version to the previous version, and from the previous version to the next version. So we demarcate those versions on both documents. Maybe we put them in the same folder, right? So that's basically what we do when we create versions in real life. And that's when we get the chain model. So in the center, you see your document as is, at the N, and then the older version would be the N-1 version, and the newer version would be the AN+1 version. Okay. For our project, we have specific requirements. So we were already dealing with a quite complex project. So we wanted to configure this versioning system once and then leave it alone. So it shouldn't add to the complexity too much. There was already too much going on. It shouldn't slow down the agility of the project. And it should work with that thought, basically. So if you're developing a microflow, you do some sort of commit, no thinking about versioning, you just develop a microflow. And it should be simple and easy to understand. So those were the requirements for versioning in our project. So let's see now about the actual model. So there are two options, and I'm calling it upfront and backwards versioning. These are the four bits I'll discuss. So let's start with the domain. So for your history object, you can create a generalization. So this would be a history object with a very important self-reference at the top, in which you can actually store the link to versions. And likewise, you can create a number of microflow retrieves that can give you the previous version or the next version. So I'll come back to that later on, but basically this self-reference is what can give you access to your versions. And then you might want to indicate on the actual history object that it's archived or not, because if you want to do a retrieve and find all non-archived elements, then you can basically filter them out quite easily with this Boolean. Here you actually see specialization of history. So in this case, we're using the top entity as a generalization for the specialization request. And this basically means that request also has this current version, penultimate version self-reference. So basically it inherits everything that history has, and we can even use the same retrieve microflows. So likewise, we can configure it in one place, right? That's what we want. Then we might store instance type. Instance type is something that is difficult to determine in Mendix, especially in the front end. So it's not really possible to see if we're dealing with a request or with a history. And with instance type, you could actually do that. So in this case, for request, we would add request to the enumeration called instance type. And likewise, in the front end, we could say any instance type should be read, something like that. Or any request should be read. Then there's something with dates that is a bit difficult in Mendix. So out of the box for history, you get the created date and a change date. That's a standard given date, which we cannot really touch, right? Out of the box in Mendix. But we might actually want to store some very important dates in this history object. So we decided that create date would be the time when the very first version was created. So we call that the original. Then the version creation time is actually that point in time in which we versioned, right? So likewise, it doesn't matter which version we have, we can also always see at what point in time in the past we created the first version. You might want to use a version number. It can be practical. It's not really necessary, but it's possible. And then there's a couple of other bits here which you can just go and explore when you get the actual projects. So two approaches, upfront and backwards. In upfront, basically, imagine you have this chain of versions, right? And the new object, which you see at the top left, becomes your new version. When do you use this? When you know that there is a new version coming out. Imagine a car factory, or maybe VW, right? Volkswagen. They have a Golf with 7 iterations right now. It's been discontinued, I think. So the 7th version was the latest version. So when the design team came up with that 7th version, they knew it was going to be the last, and they presented it to the IT team and said, hey, put it in the computer now, because this is the new version of the Golf 7. That is when you can use upfront versioning, when you know already that we're talking about a new version. And it becomes the latest version in the chain. So basically, we have a new object with a change in the new object. That's the red bit you see at the top. Interestingly, if you're talking about current vendors, you might actually want to move some relations or about assigning an assignation to a user in a workflow, for instance. you will probably have to move some associations. So that's the tricky part. So imagine having a domain with 30 or 40 entities all interconnected. That is the difficult bit of this upfront version approach. And then the created date and the change date will standard be wrong, because basically we want the AN creation date to be the same date as when the original version was created. So out of the box, when you create a new object, Mendix will set the current date time as the created date. So we have to do something about that. And the change date will probably also be wrong for AN to the -1th, because if we want to link AN -1 to AN, then that will involve a change on AN -1, when actually we haven't made a change to it, right? So the red bit is on the AN object. So in that case, your change date will be wrong. So again, you use this when you're very sure that you want to create a version already, right? And actually, this is the simplest approach to chain versioning there is, because basically it makes sense, right? We have a stack of versions and we add just another one to it. But then we can also go to backwards versioning. You might wonder, hey, what do we do here? And you can see it already, right? So we're editing in that final version. And then at some point in time, we decide to commit that change, right? And then we don't know, do we need a version or not? It's not really clear. We let the computer decide on that, because sometimes decisions on whether you want to create a version or not are very complex. I'll give an example. We might say that if I change the name of an object, we do want a new version. But if we change the description, we do not need a new version, because it's perfectly compatible in a backwards fashion, right? So we may not need that extra version then. How you decide on this can become quite complex, especially in some business contexts. So this is when you use backwards versioning. So how does it work? Basically, at the point in time when you decide to store that change in A to the N, we create a copy of the database version of A to the N, dub it A to the N -1, and then basically we need to link AN to the -2 to AN to the -1, and AN becomes the latest version then. So we need to do 3 commits here and probably move some bits and bobs, etc. But there's a benefit I'll show you in a bit. So again, be careful of your dates. And again, when you use this, when the criteria for versioning are either complex or when commits can lead to automatic versions. So in some cases, if you want to reduce complexity in a certain microflow, for instance, this one, here we have a microflow with a change with events, right? There's a before commit event, which triggers the backwards versioning. It does a couple of checks. And then at this point in time, we do not know whether there is a new version. So imagine that instead of that close page, we were to start a new workflow activity. Do I have to do a new retrieve or not? There could be a new version. If we want to start a workflow, we would want that workflow to work on the newest one. With backwards versioning, if the criteria for versioning are complex and you want to take away that complexity, this is the way to go, basically. So it's a bit more work because you store all your logic in a before commit event, but once it's there, it's really compact. So I'll show it to you in a bit. So let's look at retrieves. So you might have thought, hey, self-reference, that's nice. But if I want to retrieve an object from cache, then I have an issue because Mendix only allows me to do a one-way retrieve from the child node to the parent node. So it's a one-way retrieve for association retrieves. How do we deal with that? It's a fairly simple solution. You can use a Java action with one line of code. It's actually like this. So one Java action, you put the history inside, and then it's core.retrieve by path, get context, and then the 2 bits here is the module name and the association name. That's all you need to do, and then you get your objects. That's it. So basically, I forget about this. I have this, I made this once in the past. And then if I need it, I take it back and replace those 2 bits. That's it. So that gives you bidirectional association retrieves. And likewise, you can construct these 4 microflows, right? So they're either to get the newer version or the older version. And you can either choose to have an association retrieve, which first checks memory and then the database, or a direct database retrieve. So let's start with those. We probably all know this one where we do a retrieve, okay? And then here we can use the reversed function on an XPath that actually gives us the reverse option. So also, this is complex, right? So am I getting the newer ones, the older ones? I forgot about this. Basically, you create these microflows and put a good label on them so you don't have to think about order anymore. That's too complex. You want to forget about that. So for the association retrieves, to get the newer one, you have a standard retrieve. And to get the older one, you use that Java action I just explained to you. Okay. So we've just discussed, but there's one more thing. So if you're retrieving history, you only have those 4 flows, right? You may have to do a cast to get to the specialization. So in this case, if we just retrieve, let's say, the older version of this history via an association retrieve, then it's fine. And we have a history right there. If I want to get the actual type that is in there, I need to cast it to a request. So this is a type of cast flow. If you haven't seen any cast flows, now you have. Go ahead and experiment with that. Another really nice thing that this pattern allows you to do is to basically say, okay, if I have 7, 8, 9, 20 versions, and I want to get to the very oldest or to the very newest version in a chain. So I'm somewhere in the 5th. How do I get to the final one or the first one, right? There's a very nice way that you could do that in Mendix. It's by using a recursive retrieve. So here we're using this history get newer version from the database that I just showed to you. We're putting that history in. If the newer is not found, then we're just returning history. If it is found, then we call this microflow in itself again. And likewise, it will drill down to the newest version. You can also flip that the other way around and get the oldest version. Or likewise, you can create a list and add all versions to that list. So by using recursive retrieves, you can do really optimal retrieves over association, getting all associated versions. So benefits of the chain model, we've just looked at the domain approaches retrieves. Let's look at the actual versioning mechanism in the commits. So for these 2 options in upfront, how does that work? So basically, imagine a car design, right? In Volkswagen, a car design can have a model name, a description, some engine size, they have a fuel type, maybe Golf 8 is electric, different color, maybe different options that can be selected, right? So it's just an example. But as we can see, car design is a specialization of history, and as such, earns or actually inherits the option for versions of car design to exist. So here we're looking at a microflow called act car design create new version. So with upfront versioning, we already know that we're creating this new version, right? So usually there would be a button that would say create new version. And then you would start this microflow. And what do we do here? First off, in this system, I'm limiting versions to only the latest, meaning the active version. So if you don't do that, then you could get branches. So I wouldn't do that if I were you. You can do that, but it will lead to a lot of added complexity. So basically, we said for our implementation, you can only version the latest element to a new version. So that's what we're checking here. So if it's archived, then we can't version an archived version. And of course, you could do something about that. But for now, it's just an idea to reduce complexity. So then we get the account of the current user to store the who, and we create a copy of car design, which we will call car design new version. And finally, we need to make the old version point to the new version. So no commits. We just instantiate this new object and show pop-up. And it's a history pop-up, so we can use some smart ways of using inheritance there as well, which I'll show in a bit. So then once you've filled out your details and you're ready to store, then what you need to do is basically say, okay, now we're saving history again. Let's go to our specification, car design. We need to validate that an actual version has occurred at some point in time. Otherwise, we get a lot of rubbish in our versions, right? So we don't want that. Basically, it could be something like, hey, you can only make a new car design version if you've added an option, or maybe if you have changed description. That's up to you, right? So that validation is something that you create right here and you do here. And once that's done, you can go on to the actual saving. And what you will want to do there is to first check if this is a new object. If it is, by the way, then basically it's the first version. We can just commit. That's fine. And then it may also be the case this is not a version. We're just making a small change, but we haven't decided that it is a version. Then also we can just commit that, a backwards change. And otherwise, basically, we get the previous version. Then say, hey, I'm not flagging anymore that this is a new version. We're putting that to false. Then there's a little Java action that can help you reset your creator date, which again, I'm sharing with you. So if ever you want to change some of these attributes that you cannot change out of the box, you can with this Java action. And finally, we also need to save the previous version because that's now got a reference to the new version. That's upfront version. Okay. Hope you're still awake, Shana. Okay, let's go to backwards version then. So here we're doing all of that complicated logic in a before commit event. And it'll be a long flow. And basically, let's look at this example. So I'm using purchase request, which is a starter template from the Mendix marketplace. And in purchase request, I've decided that product should now become versionable. So I've made that a specialization of history. And then regarding the complexity of this versioning, I've decided that I'm only going to version when it's actually used in a product line. Right? So if there's no database commits on product line, you can just save the change, it's fine. But if there is, then only create a version if either the name or the description is changed. I'll show that in a bit. So again, we have complicated rules for creating versions. So how do you go about? We're looking at before commit history. First, we get the who. Then, if this is a new history, we'll go down right here and say, okay, new history, creation date, account. So basically, this is the very first original that you're saving. Then it could also be that this is not a new history, right? So it's not an original version. Then what we will actually have to do is say, there's a handy tool that we could use. It's community comments.object has changed, which will basically do a comparison of the database version to what we have in cache. And that will already help us decide on whether we need to do the rest of the logic, right? Because then we need to start investigating precisely what has changed. So that's what we do here. And then if so, then we'll investigate, let's commit a history list to commit. So we'll create if it's new, if it has changed. And then if it has, then let's go to specialization or the specification. And we'll cast. We'll get the old version from the database. And in this case, actually, you could also use that sub microflow, which I haven't done here for some reason. But anyway, you could. Then we will check if the object is actually used. So again, remember that we're only versioning a product that is actually being used in a product line. So how do you do that? Basically, you model a check like in any validation, but now it's in your before commit flow. So here I'm saying, okay, product line, is it used? If that list is filled, then we'll say, yes, it's used. And so that means that we'll continue. If not, then we'll just return true and then it'll be committed. Then finally, we want to check and make sure that versioning is actually required. So in our case, we decided that either name or description, actually you see here description or vendor, should be modified. If one of those is modified, then versioning is required. So after all of those checks, we can basically continue to the actual copying. So what do we do here? First off, we create a copy. We take the old, the history to commit and the history to copy, which is the old one. We cast that into an old product, copy it, copy the attributes using a Java action in Community Commons. Then I'm doing something with GUID. You can take a look at the project later on if you want to. Then we need to make sure that we move some sort of associations, copy those. And finally, we'll add both objects to a commit list. And then right here, we can actually check to see the who part, right? So is the account who created this version the same as the previous one? If not, we check that. And then basically, we might want to do something with a version increment. And then finally, we need to reorder all of those versions. So we've got three, actually. We've got the old version. That's n to the -2. That needs to link to n to the -1. That needs to link to the current version. So in this case, if that version exists, we need to do some more reordering, do something with the dates, and then commit at the end. That's a very quick recap of versioning. Again, this is something that you need to investigate with a breakpoint in your project, which I'll allow you to do later on. So let's go to a bit of a demo on the UX. So what should it look like, versioning? And let's see if I can open my project. Go right here. Don't mind. Thank you. So again, we're looking at purchase request. I think this mouse has been killed. And we're just signing in. Basically, there's one big important element. We just saw that little fork icon, right? The fork icon, which is right here in the PowerPoint, which is gone. Well, I should just show it in the screen. Fork icon in backwards versioning. Here is that fork icon. And I've got two main ways of showing that something is going on with versioning. So either the fork is gray, meaning you can click on it, or it's orange, meaning it will give you some sort of information having to do with version, right? And if you follow that through in your entire app, then you can signal in a proper way that something has changed. So how do we do that? How do we set the orange fork? This is a history object that's been cast into product. But there's a second object in here. The previous version is also in a data view inside here. And for each of the attribute, we're doing a check to see if the attribute has changed. And likewise, we can add a class. And that class will add that little orange fork. So likewise, we can already see that in this version, description has changed. Now, if I want to open the previous version, we'll use that smart system of retrieves, and we can just compare the options, and then immediately we can see that something has actually changed here, right? So if I want to figure out what is oh, this has also changed when this version was created. Interesting. Let's check it out. Oh yeah, I can see. Where's that? Some change at the end, something having to do with price, etc. So basically, that is the idea of versioning. This is what it allows you to do. You put a button on your screen and you can just open the previous version over self-reference and again and again and again. Now, obviously, I've added a few UX bits like positioning of non-modal pop-ups in this case. And the scrolling that is concurrent, right? So if I scroll on this one, that will happen on the older one as well. That is basically to help you work with versions. So if you don't do that, you need to close each and every screen separately and do scrolling again and again and again. And I think that links in really well to what Rico just told us. We don't want to repeat ourselves, and we want to facilitate ease to the user. But the key principle is actually to have a gray fork for previous versions, just to highlight that something with versioning is going on in that detail. You can do the same thing. So if I close all pop-ups right here, you can do the same thing actually by looking at is archived. So you can find previous versions if you'd like. You can also already see something with versioning is going on here with the V number, etc. Now, all of that logic regarding what goes on in the back with backwards and upfront versioning, I could show you that. But basically, I'd say open up the project later on, put breakpoints in the flows and experiment what's going on here. And then maybe, I hope that you'll have learned something about versioning in that sense. So to round off, there's an important consideration regarding this model that we haven't discussed yet, and that is inheritance. So having inheritance in your project can be a danger, especially when you have huge amounts of data inside your app. Because for each layer of inheritance that you apply, you will get an extra table, meaning that your commits will become slower. If you look through that top generalization of history, that table would become very large with all of the specifications that you have. So it can slow down your application. So be careful and maybe offload data if you can in some way. Maybe restrict or trash some older versions if you can. Maybe put those in storage somewhere so that you can retrieve them via a service or something. And then we also saw that if you want to apply versioning in your project correctly and make it easy, then it's handy to have a good front-end specialist in your project. So especially one who can deal with JavaScript plugins, that's definitely an added benefit. So go ahead and download it right here, and I'll be happy to answer your questions.